All right, this time we're going to talk about multiplication. We're going to multiply radicals, and I'll do the best I can to explain this. And let's see, I'm looking back at some of the IXL questions. Let's start here with this one. Okay, now remember what I told you in addition and subtraction. You can't add radicals. You cannot subtract radicals unless they have the same radical. Okay? And you may have to simplify it. So we talked about that too. With multiplication, it's just not true. You don't need the same radical to multiply. You just do what it says. If it's under a radical, if they're both under a radical, you can multiply them together, forming one radical. You cannot multiply a number outside of a radical to a number inside the radical. You can't go, hey, that looks like the square root of 10. That's not right. Okay? So that's not true. You cannot multiply a number outside the radical to a number inside. But let's look back at this first one I wrote down, the square root of 10 times the square root of 3. So we're going to combine both of them under one radical. And 10 times 3 is 30. So really the only thing you need to concern yourself with here is, are there perfect square factors of 30? We're going to ignore 1 and 30 because that's not going to help us. So we'll look at 2 and 15, 3 and 10, 5 and 6. Those are the factors of 30. And guess what? None of them are perfect. And so this cannot be reduced any further. So we're just going to have to leave it right there. Sometimes they're that simple, and then sometimes they're really not. So let's get to the next page, and let's talk about variables with exponents, okay? So let's say you've got the square root of v to the 4th. Anytime you have an even exponent, you can always take the square root of an even exponent. Always, 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 always. That is so easy. And the answer is it comes out of the radical and it's half the original exponent. So let's try that one again. Let's do a to the 8th, square root of a to the 8th. Well, that's just going to be a to the 4. Now, why is that exactly? Well, it goes back to our exponent rules that we learned. If you multiply the same base, here a is our base, if you multiply the same base, then what you do is you add the exponents, and that's going to give us, looky there, a to the 8th. And so that's why we take half of it. Here's another reason why. Remember we talked about in the crook of the elbow, if you don't see a number, it's an understood 2. So another way to rewrite this is you can bring it out of the radical. Here's your exponent divided by the root number, and you get a to the 4. So a couple ways to look at that. You may encounter on IXL, you may see some problems where they're like, hey, take the square root of a to the 5th, and you're like, oh man, I can't do that. Well, actually you can. Let me show you. You're going to just peel one of the a's. Only one a makes it odd. So peel that one a off. There it is, a to the 1st power. And we know that we cannot take the square root of a to the 1st power because the 1st power is odd. I cannot take the square root of an odd number. But you know what? All even exponents, always perfect. I can take the square root of this number. And so I'm going to end up with the square root of a to the 4th is going to come out of the radical, becoming a squared, and then I'm just going to bring the square root of a over to the side. You can do that for any odd exponent. Let's do another one. Let's do 7 this time. Okay, remember? Peel one away, peel one off. I always write it second. I don't know why. You can write it first. It doesn't matter, I guess. And remember, your even exponent is perfect. So that's going to become x to the 3rd. Half of 6 is 3. And then I can't take the square root of that odd exponent, x to the 1st. I can't take the square root of it. So you just bring it over. Does everybody kind of see what's going on there? So let me pull some problems that I saw in IXL. And here's one. This came right off of IXL. In fact, I think Kanan gave me this one to try to show her how to do. And I bet it'll help you. Okay, so as you can see, I'm multiplying these two together. So if it would make it easier for you to just put them all together into one square root, then do it. 2 times 5. Well, that's 10. Probably didn't miss that part. Where you might have missed is when you multiplied b to the second times b to the fifth. You may have kind of confused your exponent rules, and you may have thought, oh, I'm multiplying, so I better multiply the two exponents together. No. Remember, when you multiply the same base, add the exponents. This becomes b to the 7, not b to the 10. That may be where your mistake is, okay? The only way you can multiply the exponents is if you raise a power to another power. Here you multiply. That's b to the 10. This is not, okay? So now as we look at this one, we go, okay, can I break down the square root of 10? And as you think about the factors of 10, you only have 4 factors of 10. Remember, 1 and 10 aren't going to help you, and all you have are 2 and 5. Well, guess what, guys? They aren't perfect, so you're not going to be able to simplify the square root of 10. So we'll just drop that down. Now, let's treat b to the 7 like we did on the other page. It's odd, so let's peel that one odd one off. And the rest of them, we have 6 left. Okay? That's perfect. That's the only perfect thing about this entire radical is we can take the square root of b to the 6. Remember, it's half the number it was, b to the third, times, and then go ahead and put these two back under one radical. And that's how you would type in your answer. B to the third times the square root of 10b. I'm looking at my list here. Let me see if there's some other ones. Let's go to another page. Another one off of IXL. 63, square root of 63 times c to the 9th. Okay, 63. You can go through your list. 1 and 63 aren't going to help you. That's okay. 2 won't go into it. You got 3 and 21. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 and 9. Whoa, Nelly, I think we found it. That 9 is perfect. 9 times 7 is 63. I'm going to circle the 9, not the 7, because only the 9 is perfect. Now let's look at that c to the 9th. Let's take that odd one off, and then we'll put the rest of them under a radical. And the even exponent is perfect. So let's take the square root of 9, that's 3. The square root of c to the 8, that's c to the 4. And then we'll put these two back together under a radical, and I'm simplified. Are you seeing kind of how it's flowing a little bit? Okay. Let me see if I see anything else on here. Yeah, there's a couple others. I don't know if we've done this one or not, but I'll try it with you. It's the square root of 5 times the square root of 3k to the third. You can put it all under one radical. It's fine. It's not going to hurt anything to just go square root of 15k to the third. Now 15, you're limited. There's only 4 factors. 1 and 15, 3 and 5. None of those are perfect. So you're kind of landlocked with the 15. You're stuck with that one. The k to the third, not so much. Let's peel the 1k that makes it odd and put the other 2 under its own radical, and that becomes perfect. And so the square root of k squared is k, and put these 2 back under one radical. And you are finished. That is how you solve that. Okay? So I'm trying to see if there's anything else I can show you here. I don't think so. I'm going to stop the video right here because we're right at 10 minutes. If you have any specific questions, make sure you call, text, or email me. Okay? Good luck.